All right, so there's some other things about systems of equations that I'd like to cover, just that we have kind of gotten through everything. One thing is how to deal with how an ugly looking system of equations. So by ugly looking, I mean a system of equations that either has fractions or decimals. So we're going to tackle the fractions first. We have two options for dealing with these fractions. First option is to just get rid of them as I would normally do whenever I have fractions in an equation. Because if we recall, it is completely okay of us to multiply through both sides of this equation by 15. It's still going to give us an equivalent equation with the same solutions, so we could go ahead and do that. And if we multiply by 15, we're choosing 15 because it's the least common denominator between 3 and 5. So it's going to cancel out both of those fractions in one swoop. So if we did that, we'll get 5x plus 3y is equal to 105. And then we can do the same thing with the bottom equation, get rid of its fractions. 6 and 5, the common denominator would be 30. We multiply that out. We are going to get 5x, what is that? Brain is not working, minus 12y is equal to negative 120. Tried to not multiply the non-fraction part, which is a very common mistake that students make. So at this point, we now have two pretty systems. So the first thing I'm going to do, because I forgot to mention it in the elimination video, is show you what a very common mistake students make is. With elimination, or addition as the book calls it, a lot of students, what they'll do is they'll just add the two equations together. So, okay, now I have 10x minus 9y is equal to negative 15. And then they don't know what to do, because all they have managed to do is make a new equation. It still has two unknowns, and they'll usually do something very creative at this point, like set x equal to 0 and find an intercept or something like that. The point is that we were not supposed to actually add yet. We don't want to add until we have made our two coefficients on one of our variables opposites. So I have decided that the x's seem like they're going to be the easier ones to deal with. They already match. We just need to make one negative. And I'm going to go ahead and multiply the second equation through by a negative 1. I'm choosing the second equation because these negatives are going to turn into positives, which seems nicer to me. So if I do that, I'm going to get negative 5x plus 12y is equal to a positive 120. And then I can go ahead. This is now the opposite of my first equation, so I'll rewrite that. 5x plus 3y is equal to 105. And now we're ready to add these two together, right? The whole purpose is these two things are opposites, so when we add them, this is going to become a big fat 0. I don't even need to write it. And then we have our 15y is equal to 225. So that is the whole advantage or whole purpose of elimination. If you add these things and you don't get your variable canceling, you haven't properly done elimination and you really can't do anything yet. So once you got that first step down, now we can finish solving for y and find that our y is equal to 15. And then it's up to us. Now that we have a y, we can either plug back in to find an x, and we have three options for where we could plug in for this. We could plug into the first equation, the second equation before we modified them. We can plug into the ones that don't have fractions. Any of those are fair game. Third option, or the second option besides plugging in somewhere, is to just do elimination a second time. And that's actually what I'm going to opt for here. So I'm going to just rewrite my two equations. We had 5x plus 3y is equal to 105. I'm going to use the nice non-fraction versions of them. Actually, we could do that, but we did a lot of that before. Let's see what the second option would be to handle this in the first place. Another thing we could have done to handle this in the first place would have been to just go ahead and leave the fractions and embrace them. And that's not so bad with the y's here, because we can see the y's, we have a positive 1/5 and a negative 2/5. Those things are pretty dang close. In fact, if we just took this top equation, the top equation, and multiplied it through by positive 2, well, the result would be 2 over 3x, right, because this is a 2 over 1, plus 2/5 y is equal to 14. And now look at my new y's. They are opposites of one another. So I can go ahead and add these together. Easy enough on the right side, -4 and a positive 14 give us 10. The y's cancel. The hardest thing to do here is to add this 1/6 x plus 2/3 x. What does this equal? You can't just type this in your calculator. If this was 1x plus 2x, we would just add them together, right? The 1 and the 2. So that's exactly what you're going to do. You need to figure out what 1/6 plus 2/3 is in order to combine these like terms. And this is something you can do in your calculator. You could use your common denominators to do, right? So we could rewrite this as 1/6 plus 4/6. This is all going to be 5/6. So we finish that up. We get 5/6x. Now, like I said, this does not seem to me like it's easier than what I did on the right side, where I cleared the fractions first. But with the calculator, adding 1/6 and 2/3 is really not that bad. And then if we wanted to finish this up, we can multiply by the reciprocal or divide by our fraction if we have the calculator. And we're going to find that x is equal to 60/5, which is just 12. So our final answer, as we see it right now, looks like it's 12, 15, that ordered pair. Before we box it up, let's go ahead and check our work. We either have 1/3 times 12 plus 1/5 times 15 is equal to 7. It is important when you check your work, you want to use the original equations, not the ones that you modified, because if you made any mistakes when you multiplied through, you're not gonna catch your error. So this is 4 plus 3 is equal to 7. The first equation works. And the second equation, 1/6 times 12 minus 2/5 times 15 is equal to -4. 2 minus 6 is equal to -4. Also works. So we can box this up. We have managed to conquer the ugly fraction problem. And like I said, two ways. Get rid of the fractions and just deal with these new beautiful equations that don't have fractions, or embrace the fractions, use your calculator to help with the fraction math. So what about decimals? Decimals, you have the same two options. You can either go ahead and say, all right, I don't like decimals. Let me multiply by whatever power of 10. Since there's one decimal place, I just need to multiply by 10 to clear them, right? So for the first one, we'd have 3x plus 2y is equal to 50. And for the second equation, we'd have 5x plus 4y is equal to 110. And then we can do our elimination from there. Alternatively, you can embrace them sort of like we did before. We could have also just said, okay, if this is what we're dealing with, then we can see the easiest thing to eliminate here is going to be that y. I can make 0.2 or 2/10 into 4/10 by just multiplying through that top equation by 2, a -2, right, to make it the opposite. And then if we do that, we have -0.6x minus 0.4y minus 10. And we can definitely add those together, giving us -1x is equal to 1. And x is equal to -10. We could do the same work over here, though, with our new versions. Again, y is going to be the easier one to eliminate. We could just multiply through by -2 again. It's the exact same math. You're just going to have no need to work with decimals. But again, with a calculator, decimals aren't nearly as scary. Just to finish this one up, if we got x is equal to -10, we could then plug it back into one of the equations since I didn't do that last time. We'll go ahead and use the top equation. So we get -3 plus 0.2y is equal to 5. 0.2y is equal to 8. Then we're going to pretend that I can do that math in my head, which is absolutely untrue. So fraction math and or decimal math and I don't get along. Y is equal to 40. And then we should check. I actually made this video before and totally made an error. When I multiplied this by -2, I wrote down -22 here. I multiplied the second equation for some reason, and that's when I ended up in trouble. So let's go ahead and check our work, because the first time around I didn't, and then bad things happened when I went to go finish up these notes. I was like, oh God, it didn't work. So 0.3 times a -10 plus 0.2 times 40 is equal to 5 is one check. The other equation is this. So we just got to check out and see if those two work. So -3 plus 8 is equal to 5. Boom, first one's good. The first one I wasn't as scared about, though. It's the one I used to go find my y values. So if anything's off, it's going to be in the second one. -5 plus 16 is equal to 11. Hooray! I didn't screw it up this time. -10, 40. That's our beautiful ordered pair to solve this thing out. Okay. So I'm actually going to save the last topic for a different video because I'm running low on time. But that's how to deal with fractions and decimals in our systems of equations.